sure the screen's active and go ahead a slide. Yeah, so I guess you all are a crypto club. Is that right? Yeah?
Yeah.
No, it's cool. Fantastic. I'm going to ask some questions, so we're going to have some hand raising and stuff, just FYI. Fantastic. Well, I am Richard Gottlieb. I work at Chainlink Labs. I'm going to talk about Chainlink. I'm a developer advocate. That just means I get to spend my time learning stuff, making projects, talking to cool people. It's a pretty cool job. My Twitter is rgottlieber, and that's my email, richard.gottlieb@Chainlink Labs. If you want to reach out, say hi, ask questions, whatever, feel free to reach out. Cool. Sorry, there's a pop-up. I think everybody's in though, yeah? Okay. Patrick, I don't know, can you admit people from your end?
Yeah, I can admit. Yep, I can admit people.
Okay, cool. I will ignore those then. So besides being a developer advocate, I'm also kind of a nerd, and I like to play this game, Magic the Gathering. Anybody familiar with Magic the Gathering? Yeah? Oh, this is gonna be good. So for those of you who don't know, Magic the Gathering is a collectible card game, and collectible card games come with a couple different aspects that kind of make them interesting. First of all, the cards come in these packs that are theoretically random. They also have this aspect where you need to collect the cards to build decks to play the game. Collecting cards can look like either buying them from a retailer, trading them, and when you're trading them, you can run into issues like maybe I think a card's worth $100 and you think it's only worth $10. So we need to have some sort of agreement there, come to consensus on what the value is of these cards. I know you're all probably like, wait a minute, I thought this was about crypto and smart contracts, not Magic the Gathering, but there's a connection here. When we're talking about prices and coming to consensus, right, we have to trust the source for that information. We have to trust each other that the card is actually a legitimate card and not a copy or a fake card. And that can be problematic, right? Trust is great when it works, but the fact that it doesn't always work is a problem. That's where smart contracts come in. I personally think that smart contracts are going to revolutionize agreements and how people interact going forward because they take that trust piece and they replace it with truth, right? Smart contracts built on top of blockchains allow us to have cryptographic-based truths that can replace this trust-based system. Cool. That is huge, right? So traditionally, when we had an agreement, I know we're talking about magic cards, but let's transition now to thinking about contracts in general, right? You have a contract and normally you think, oh, this is just between two people, right? Like Travis and I have this agreement and we sign this piece of paper so we know it's going to happen, right? Essentially though, you have outsourced the enforcement of that agreement to a third party. It works pretty well for the most part here in the United States, but it doesn't always work. And again, the not always working really kind of sticks in my craw as like being a problem. Smart contracts, again, can fix this problem, right? They get rid of that third party. So we don't need anyone else other than the two people making the agreement to interact with each other. And we're guaranteeing that they will do what they say they do, right? We're transitioning from trust back to truth. I think that's really cool and really powerful. And I think that's gonna is the future. Now, in order for smart contracts to work, they need to live on a blockchain. And blockchains have this huge benefit of being decentralized, where there's a bunch of different nodes that all come to an agreement or consensus on the results of something. And it's pop quiz time. Who here agrees 1 + 1 is 2? Yeah, okay, good. I'm glad we agree on that. So that is a deterministic value, right? Anytime you have something like that where it's always going to be the same answer, That's deterministic value. And all the different nodes in a blockchain, they can agree upon that. Great. Now, sometimes you might want to have a value that's not deterministic. Like, who agrees that the temperature, I'm just looking at my Apple Watch here, the temperature outside is 44 degrees right now? No? No?
Depending on where you live.
I just checked though, it's 44 degrees. Yeah, it depends, right? It depends on when I ask you that question, where you are, right? There's lots of different things that can impact that value that's coming back. So that's kind of a non-deterministic value. Anytime you call an API like that, like thinking about like weather, for example, calling a weather API, the value can be different, right? Generating random numbers, that can be different. Non-deterministic values make it very hard to reach consensus. So that brings us to the problem that blockchains, they live in like this deterministic bubble, if you will. The smart contracts need to reach consensus, like all the different nodes verifying results need to reach consensus. So you have this great capability of cryptographic truth-based things, but it's essentially completely disconnected from the outside world, right? Like that's kind of a limiting factor, and you need something to fill that gap. The thing that fills that gap is an oracle. So an oracle enables you to bring data from outside a blockchain on-chain. That's exactly what Chainlink does. They bring that data from outside the blockchain on-chain. Now, is it possible for you to set up your own oracle? Yeah, it is. You could build an oracle node and call an API. We can just stay with weather for this example, right? They can query like the weather data, and you can have that node set up, and it would work. Now, one of the things that was really powerful about blockchains is the fact that they're decentralized, right? If we have a single node, is it still decentralized? Yeah, not anymore, right? We've taken all this power and we've made it centralized. Also, like, we've introduced the ability for the node to go down and disappear. Suddenly stuff doesn't work anymore, right? You have one single point of failure. You've also introduced the ability for a bad actor to come in, right? Perhaps you are looking at the weather and something happens if the weather gets too cold and the node gets compromised or is malicious and never reports cold weather because they don't want that to happen, right? This is kind of the problem of centralized nodes, and Chainlink approaches that by creating a decentralized node network. That means we have an off-chain network of Oracle nodes that all come to consensus. They're run by independent operators, so it's not just controlled by one entity. So you have decentralization of control there. They are focused on data validation and reaching consensus. And then they also are reviewed for security, and they have their performance data is stored for historical purposes so they can be reviewed. This enables us to fix that Oracle problem in a manner that keeps the decentralized benefits of blockchain networks. You might be wondering, okay, cool. So he's like mentioning this coming to consensus, and he said non-deterministic values are hard to get to consensus, right? Like that could be a problem. Well, the way that is approached with Chainlink, if we look at something like price, okay, we have this network of nodes that's reporting the price back to us, and each node has their own opinion on what the price of something is, right? If you think back to Magic cards, when I was first getting into Magic, they're like the most beautiful illustration of supply and demand, right? Things that are in high demand are worth a lot of money if there's not a lot of them. And thinking about that, and like different places might have different supplies of something, and so the price could be different, right? So you have different values that are reported for the same asset. The way that Chainlink approaches this problem to reach a consensus and a deterministic value is each of the different nodes in the node network reports their price to our smart contracts on chain. They sign it and verify that, like, yes, this is this node, and this is the price that I'm reporting. The contract then takes those values and aggregates them together to one deterministic value. So you kind of have this history of what everybody reported. You know the method for reaching a deterministic value, and then that value is stored on chain. So you're taking the node network, coming to a deterministic value based on a non-deterministic origin, and storing it on chain. That enables what we like to call hybrid smart contracts, right? So traditional smart contracts, they're kind of trapped in that bubble that we mentioned earlier. Hybrid smart contracts enable you to take external data not on the blockchain, and bring it into the blockchain to inform your smart contracts. This is really powerful. Let's take a look at a few of the different ways that Chainlink does this and the different products that they offer. So the first thing that we're going to talk about are data feeds. It's pretty simple, straightforward. Data feeds are getting data from off-chain, on-chain. VRF is a verifiable randomness function. Essentially, when you see VRF, just think random numbers that are secure and verifiable. And then Keepers is a decentralized network of off-chain compute power. So we're going to talk about each of these products in more detail. And when I get done talking, we're going to do a little demo of data feeds, and so we can see how to actually use that. So starting off, data feeds. Let's bring off-chain data on-chain. This can be anything from a web API call to pricing data to basically any other data source that you want. Essentially, if it's an API, you can get that information from our Oracle network and bring it on-chain. One of the most common use cases of this is price feed data. And price feed data is used by projects like Aave, SushiSwap, Synthetics, Compound. These are all different DeFi applications that use Chainlink price feed data to empower their products. And currently there's $76 billion worth of assets that Chainlink data feeds are powering. Kind of to dive into this a little bit more, the way that this works is we have these exchanges where the different assets are priced. The data providers then query those exchanges, get the information, take that information, and the Chainlink nodes each report the asset valuation to the Chainlink reference contract, the aggregator contract, and then user contracts can interact with that aggregator contract to bring that data into their applications. This is actually the example that we'll be going through in the demo. So we also have data.chain.link. This is where you can see our data feeds. Let's go ahead and take a look at that. If you go to data.chain.link, you can see some of the popular feeds that we have here, along with the different networks that we support. We support things like Ethereum networks, Arbitrum, Phantom, and there's more coming all the time. This is another point to make. Chainlink is network agnostic, right? We are trying to be across all the different chains and provide this Oracle network to all the chains. If you take a look at a data feed like the ETH USD pair, you can see the valuation that's being reported by the Oracle network right now. On the right-hand side, you'll see I think it's 31 different oracles that are reporting in their individual prices, as well as the trusted answer, the aggregated answer from all those oracles. A couple of things to point out here. There's the trigger parameters. Anytime that one of these is met, it will update the price. So the smart contracts on the blockchain will be updated with a new price when these parameters are met. It can either be a change in price of 0.5% or when that heartbeat occurs. So every time that heartbeat occurs, looks like the next one's in 40 minutes, it'll update. And it was last updated about 20 minutes ago. You can also see down just a little bit, the actual address for the contract where this price feed is stored, as well as the ENS version. There's some more information like the history of the asset, and then data on the actual oracles that are reporting the price as well. So I guess I'll pause here for just a minute. Like, if we have do we have any questions so far?
I have a question.
Go for it.
So let's say like you have an individual developer who just wants to make like his or her own data feed and put that into like their own smart contract. Is there any way that Chainlink or does Chainlink provide like an opportunity for people to like easily make new data feeds, even if it's just like one oracle that's reporting?
So there is a method to request a data feed, yes. If it's a price specifically one, I don't know why I zoomed in a little bit. If it's a price specifically, you can request it right here. Also, I can show you in the docs later when we're going through the demo, there is a way to pull in other APIs as well.
I also have a question. So for that example, with those 31 different nodes, do you guys have any algorithms in place for if a node is like acting as an outlier, if one of the 31 produces some value for Ethereum that's way off everyone else's, do you guys usually just cancel that one out or still like find the average using that outlier value?
I honestly don't know offhand what the algorithm is for calculating this.
Okay.
If you want to hit me up on Twitter, or email me, I can let you know. I can get that information for sure though.
Sweet, thank you.
Okay, we'll go on to VRF. When you say VRF, what do you think? Random numbers, cool. So VRF is a way of generating a verifiable random number that you can use in your smart contracts. Why is that important? When we're talking about random numbers, true randomness is very hard. And when it comes to deterministic values on the blockchain, it gets even more fraught with like danger, I would say, right? When you're generating a random number in a smart contract, a very common practice is to do something where you take some sort of seed and you hash that to generate your random number, right? That could be the current block hash, the time, the address of the person or contract that's calling that function, right? There's different things you could use, but every one of these kind of suffers from the same issue that when that block is being mined, the miner can see what the outcome, they could see what the outcome would be and choose to give that block, like to return that block as mined or not, right? So if you're using like the block hash, for example, they could wait until it was favorable for them. So you have the possibility that the person interacting with the contract also has the ability to influence the randomness of the number that's being generated. Now, if we're just talking about like, generating an NFT and the traits there, maybe not a big deal. But if we're talking about like a lottery result and we're talking millions of dollars, it might be worth your time to try and influence the outcome of that lottery, right? This is where Chainlink VRF comes in. They enable you to off-chain via the Oracle network, generate a random number that has a proof with it that is then submitted to the contract where it is verified that yes, this number was generated and it's correct and it was fairly generated randomly. That's huge. Some examples of this, like Pool Together, I don't know if you're familiar with them. They run a lottery that's a no-loss lottery, which is actually kind of a cool idea. Or like you put money in and if you don't win, you get your money back, but the winner gets the interest. And Avogacci, for example, they generate traits for their characters using Chainlink VRF as well. But that's the second thing is VRF. Questions about VRF?
So does
Cool.
Avogacci make NFTs using the Chainlink random number generation, right?
Yes. Yeah. The traits for the NFT are based on random numbers from Chainlink VRF. Cool. Let's move on to the last thing. Chainlink keepers. I like to think of Chainlink keepers as, well, first I have to ask a question. Is anybody familiar with Unix, the operating system? There's a command in there called cron. It basically lets you schedule. It's a scheduler tool. And cron enables you to say, at a certain time, I want this event to happen. Chainlink keepers is essentially cron for smart contracts. So smart contracts are smart, but they don't do much by themselves. They need something to kick them off, right? And that's where Chainlink keepers come in. They are, again, in the network of Chainlink nodes. They enable you to set conditions in order to trigger functions within a smart contract. They also can trigger not just based on time, but based on events, right? So anybody familiar with if this, then that? Zapier, these type of things, right? Where like something happens and then that causes something else to happen, right? Like kind of like a Rube Goldberg machine. Yeah? That's Chainlink keepers. They can automate contracts. You can use them for things like yield harvesting, triggering different events, right? If you want, going back to the example of pool together, like when you actually execute the lottery and run it and pick a winner, right? You can have that triggered by Chainlink keepers. Questions about Chainlink keepers? No? Cool. We're going to run through a demo. Now, I think we've got enough time. Do we want to just watch the demo or do we want to try to do the demo together?
We'll just watch. It'll probably be a little too difficult to all do the demo together.
Okay, cool. I think that you all, if you want to later do this demo, should be able to do it. It's only going to take about 3 minutes, and we're going to go to the docs, use the docs to deploy a smart contract onto the Coven test network, so an actual test network. We're going to then interact with that contract, which will use the Oracle network to get price feed data for ETH USD on the Coven test network. So if we head on over to docs.chain.link, this is where everything lives to tell you how to do everything with Chainlink products. We've got them sorted by chain type. We have EVM chains, so things like Ethereum, Polygon, Arbitrum, Solana, and Terra. There's a little bit of differences between those different chains. If we head to the data feeds piece, we can learn about data feeds, but we're interested in actually using the data feed. Head to using data feeds, and it'll explain to you what the feeds are, how to use them. And then we run into this awesome example here, this contract that is huge, right? Like so much code to bring off-chain data on-chain. Not really. At the bottom is this open and remix. Has anybody used Remix before? Yeah, a few of you? Remix is really cool, in my opinion. It is essentially a web-based IDE that lets you use Solidity from your browser, and you can even deploy it to the blockchain. So you can deploy straight to Ethereum mainnet from here, like a full-on smart contract, and you've just been in your web browser. I don't know, blows my mind sometimes how far technology has come. Let's take a look at this contract real quick. The first thing we have here is an import, and this import is actually importing in one of Chainlink's contracts. That's the aggregator contract. So this is the contract that's going to take those prices from the Oracle network and kind of return the aggregated result to us. This is where that off-chain data that comes on-chain is stored. For this example, we're creating a contract that's called Price Consumer V3, and we're declaring a price feed that is an aggregator interface. There's some notes here that kind of tell us a little bit about what we're going to be doing. The first thing to note is the network is Coven. So within the Ethereum ecosystem, there's a few different test networks. In this case, we're using Coven. There's also Goerli and Rinkeby and some others, but we're focusing on Coven here. It's letting us know what aggregator we're using, It's the ETH to USD, and the address for the contract, right? Now, what if you wanted a different asset pair, right? Like maybe you're not interested in ETH USD, you want to know some other price pair. Where would you find that? Well, we could either look at data.chain.link, right? Because it tells us the contract address here, or in the docs, we have a list of contract addresses based on chain. And if we take a look at the Ethereum ones, you can see we have quite a few different price pairs that are available, but you would need to change the contract address for each of these to get the right results. Again, we're focusing on the ETH USD pair. So when we create our contract, we create our price feed, and we let it know the contract that we want to use. And then we have this function, get latest price. It's going to return the latest price from that contract. We're going to call our price feed and call a function, latest round data. Latest round data returns quite a few different variables. We're interested in price. If you want to know what the rest of these are, you can take a look at the docs. But the price is going to be the price of Ethereum in this case, in terms of USD. So if we want to deploy this to the actual blockchain, we click on the deploy button here. And since we're interacting with an actual contract that's deployed, we need to change our environment. This is kind of like a local virtual environment, which is great for testing. And if you're just working kind of like self-contained within a smart contract, that's awesome. In our case, we want the injected Web3, which will take the information from our wallet so that we can deploy to an actual test network. And one other thing to note with Remix, this always catches me. That's why I tell people is so that I don't goof up. You need to change the contract to make sure it's the one that you're expecting to deploy. In this case, we're deploying the contract named Price Consumer V3. The other one was this one that we imported up here. We don't want to deploy that one. We'll deploy it. It's going to tell us it's going to cost some gas. We'll say yes. If you want to do this later on your own, you're going to need some test ETH. Faucets.chain.link is a place where you can get test ETH, just as a pro tip, because it does cost money to do things on blockchain networks. Or I guess it costs coins. Okay, cool. We've deployed it, and you can see here we have our deployed contract and our function, get latest price. If we click that, we'll actually execute that function on the blockchain and get back the results. Now, this number is pretty big, right? Like, that is quite impressive. The reason it's so big is because Solidity does not have the concept of decimal places. Essentially, this number is multiplied by 10 to the 8th power to account for that. So you'll need to come back and put in 8 decimal places to get the actual, USD value. So you can see here that this contract is reporting back $2,417. This is the price of ETH in terms of USD on the Kovan network. So we talked about smart contracts. We talked about data feeds, random number generation, keepers. We even actually deployed a real contract onto a blockchain. And that took less than 5 minutes, I think, even with all my jibber jabbering on about what things do and buttons. So where do you go from here? We have a Discord that you can join if you have questions, want to hang out. We have starter kits on GitHub. Starter kits basically give you everything you need to start building a application using the blockchain Chainlink products. Our documentation that we looked at, docs.chain.link. And then something new that we just launched is the Chainlink Academy. It's at chainlink.education. At this point, what questions do you have?
I have a question kind of going back to the process of requesting a new data feed. Can you talk a little bit more about that and I guess what are all the steps to get a new asset? For example, if you wanted to get Cello on Chainlink, how do you have enough people requesting that data feed to the point where you guys actually add it?
So I don't know, Patrick, if you can chime in on this one. I know that the process is you need to basically get the Oracle network to support it.
Yeah, I can jump in here. Hey, how's it going, everybody? I'm Patrick. I'm here just a shadow. Richard's been killing it. Yeah, really good question. So the first thing to keep in mind is Chainlink is a decentralized Oracle network. So anybody can spin up a node. Anybody can spin up a network. Anybody can really do anything, right? That's the beauty of decentrality. You can kind of do whatever you want to do. So if you want to spin up your own, great, you absolutely can. You will likely then run into the issue that a lot of people run into, which is it's incredibly expensive to do a lot of updates on a lot of these networks, right? Because every time you make an update, you pay what? Does anybody know? What do you pay when you make a transaction on chain? I heard somebody like mumble gas, but that was correct. Yeah, you pay gas, right? You pay this transaction fee, right? And this is why actually these price fees, these decentralized networks are so powerful, right? Because you have this economy of scale. You have hundreds of protocols all paying the same data feed, which drastically reduces the price, making it even cheaper than if you went out there and created your own Oracle, right? Because everyone's paying for it, everyone makes it. So you can do that, but it's going to be expensive. Now, so the other thing is, okay, how do we get our data, our piece of data, onto an existing data feed, right? Onto an existing Oracle network. That's when, so that request a price feed goes to one of these existing Oracle networks, right? So anyone can make one. But it's often just a lot easier just to add it to, because they already have the infrastructure running, they already are getting paid from other data feeds, et cetera. Anyways, but so it comes, so the question then becomes, how do I get a new data feed onto an existing Oracle network, right? So the answer there is it depends. Depends on who wants it, right? Because data isn't cheap. So all of you are in college, and there's a lot of free APIs and stuff, which is great. Once you get to the point where your data is responsible for billions and billions of people's money, the free endpoints start to not become so good. Either the data isn't that reliable or it's not that high quality. So you start trying to pay for better data, right? And so just adding a single new endpoint isn't trivial. A, because you have to buy the new data. B, because you still have to get this whole decentralized network of oracles to adopt this new piece of data, start delivering this job, and they're again paying for gas. So you do need protocols interested in this data feed to pay to help support it, basically, because again, every time you make an update, you're paying gas. So the answer there is really it depends. If enough protocols want it, and if enough protocols are willing to help sponsor it. Because at the end of the day, like I said, data isn't cheap. Making transactions aren't cheap. And that's basically the process there. So it's a little bit gray, but yeah, there's two paths. There's one where you just do it yourself and you explode your bank account. And there's two where you get it added to an Oracle network, but likely you'll need a group with you as well. Does that make sense? Does that answer your question?
Yeah. Thank you.
And
Great question.
that brings up another point too. I didn't scroll down this far earlier. When it comes to data feeds, they are free to use, right? And to Patrick's point, it's not free to create these and to keep these updated. When it comes to how are they free to use, all the way down here at the bottom, you can see who the users/sponsors of these different data feeds are. So essentially what happens is if you are relying on this for a project, you are incentivized to ensure that the data is high quality and that it's always there for you, right? So you end up contributing to the costs of keeping those data feeds alive as well. So you can kind of see some of the sponsors.
I have
Other
another
questions,
question.
thoughts? Yeah.
So in the future, do you guys see a world where people are using Chainlink data feeds, like in physical areas? So maybe like in the supply chain industry, you might have like a whole series of like cargo ships or containers and trucking do you see like physical like sensors keeping track of all this data and then that stuff being used in smart contracts?
Yeah, so that is like you're like hitting the right on the nose, right? Like that's one of those use cases where physical sensor data, is that deterministic? No, right? Like it depends on what the result's going to be at different times. And so that is a perfect use case where getting that data into a smart contract is a challenge, and a distributed network of oracles is a perfect use case for that, right? Yeah, for sure. So yes, to answer your question, simply, yes.
How long do you think it'll take for Chainlink to get to that point?
I would say that the capability is there. It's more adoption, right? And while we use the term oracle, I am not in like the Greek sense of the term an oracle where I can predict the future.
What do you guys think about Arbitrum? I think that's built on Chainlink, correct? Are they used?
Our products are on the Arbitrum network. Yes,
Yeah.
I'm a big fan. Speaking of gas fees, because like they're
Exactly.
way cheaper. So I don't know. I like Arbitrum. Bullish on Arbitrum personally. Speaking as myself, not Chainlink Labs.
Are you bullish on?
So
Yeah, that's our next question.
Like the can you guys speak on like the tokenomics of Chainlink at all? Like what the coin itself is used for, and kind of like how the supply of the token works and all that.
So the coin is used for essentially to pay for various services within the Chainlink ecosystem, right? Price feed, the data feed piece, not so much. When it comes to things like keepers and VRF, that is where you need to, it's essentially the same concept, in my opinion, as like, why you pay gas fees, right? Like the Link token is used as a gas fee for the Oracle network to incentivize oracles to do the work, to pay for like the compute time, like of those various processes.
I can jump in and extrapolate a little bit more. So there's like a couple different things the Chainlink token does. So first off, whenever you have a protocol that's in this decentralized space, you have to figure out, okay, how do we pay the operators of this network, right? What do ETH node operators get paid with? They get paid in Ethereum. So actually, when Ethereum first came up, one of the questions was, well, why don't you just get paid in dollars? Or why don't you just get paid in Bitcoin? Why do you need Ethereum? And the answer to that is really having the token there increased the economic security of the network, right? How dependable and reliable the entire network is now directly correlated to the price of the asset, right? The more expensive the Ethereum network becomes, surprisingly enough, the more secure it becomes, right? Because there's all these more crypto economic guarantees. So it's the same thing in the Chainlink network. So there's this first piece. This is this crypto economic guarantee level, right? The link is directly tied to the value of the network. The more dependable the network is, the more steady that the node operators can be with the link token, right? So they need to get paid in a token that makes sense within the network. Additionally, the token is actually, for those of you who don't know too much about like ERC20s, it's an ERC20 token that was specifically designed to work well with oracles. So it has some additional functionality from like a regular token. It can do one of the big improvements is this function called transfer and call, where you can both transfer the asset and call an additional function. That way a node operator knows, okay, I'm getting this link token and I know exactly what they're trying to do with it. I know they're trying to get this piece of data. I know they're trying to do this keepers thing, right? So there's this, it's also required at the protocol level. Like I said, it's required at this crypto economic security level, and in the future, if anybody's read the white paper V2, there's the next iteration of Chainlink, which is incredibly exciting, includes a staking feature, which it doesn't make sense to stake in dollars or like an asset outside of the Chainlink network, right? Because the monetary policy of these other networks could be, whatever under the sun. So we need to have that the token have the same policy like tied directly to the security of the network. So hopefully that makes sense. Does that make sense?
Yeah, that makes a lot of sense.
That's a great question.
A very
Great question.
clear explanation. Thank you.
Thank you, guys.
Yeah.
I have one last question. So,
Sure.
a lot of people in the club want to work at an established blockchain company or a startup after graduation. What tips do you have for someone looking to be hired as a developer at a Chainlink company or working in a business role at a Chainlink? Yeah.
So personal tips is just like, depending on what role you're interested in, right? Like learn as much as you can about the space. That would be my first tip, because it's so new that there is like such a hunger for people to work here that, if you know a little bit, you know a ton more than most people, right? Even if you just the fact that you've listened to this talk, you know way more than most people that you'll run into today. And that is I don't know, just keep learning and expanding your knowledge about the space, I think is probably the biggest thing. I know there's a lot of just my personal experience is that there's a lot of confusion and kind of mistrust about the space because it's new for people looking for jobs too. And so that kind of pushes people away from it. Personally, I think it's the future. That's why I'm here. I previously worked at Facebook and came to Chainlink because I think this is where the world is going. So I don't know, that's kind of my personal take on it is just keep learning, and Chainlink's hiring like crazy. I think that you'll see this entire industry is growing like crazy, which is good for people in your case, right? Where you're looking to get a job soon. That's fantastic. I don't know. And it's learn more and do more, and that will get you there. And apply to Chainlink. That's what Patrick's going to say.
Yep, I was going to say, and Chainlink Labs is hiring, so definitely apply to Chainlink Labs. So there was a sorry, wait, was that the end of the question, or did you have a follow up?
Link Marines. Have you heard that term?
No comment. But yes, I've heard it.
What does that mean?
Because I am. Just want to make sure you guys are too.
Yes, I am savvy to that term.
Is this some kind of inside joke?
Yeah. Crypto Twitter shit.
The first rule of Link Marines is we don't talk about Link Marines. I don't know. But yeah, was there a question in the?
There was a good question in the chat, Richard. So from Hayden, who are Chainlink's competitors?
I don't know the list off the top of my head. Nobody is competing at the level we're at because we're the best, clearly. It's a bold statement. I don't know offhand who they are. I'm not worried about our competitors. I'm worried about us and building the future.
But your competitors essentially do the same thing. They just, they just try to get other assets and other data feeds. But in essence, it's all the same stuff, right?
I can jump in on this one. So there are a couple different oracles trying to do similar things, right? So there's Band, there's Bandchain, there's Teller, there's Umbrella, Uniswap, TWAP. There's, if you think about how many layer ones there are out there, right, or how many Uniswap forks there are out there, it's the same thing, right? There's a ton of different protocols trying to do the same thing, right? And each one of them does everything a little bit differently, right? So So at the end of the day, a lot are trying to bring data on chain or trying to do external computation. Some of them have different focuses. Some of them are, so saying they all do the same thing is, I would say in essence, not correct, right? Because maybe one says, hey, I'm an Oracle. I talk to John. John tells me the price of ETH is $1 million. So I send a transaction on chain that Ethereum's $1 million, right? Is that putting data on chain? Yes. Is that an Oracle that I would trust, billions of dollars with? Probably not. I would probably get rugged over and over again, right? Or I would arbitrage or something like that. So looking into the architecture of kind of how all of these works, I think is really important. And all the questions everyone's asking are really important, right? Because these are all, they're all different protocols with different architectures. I will say, what does Chainlink do fundamentally incredibly well? It's security, decentrality, and right now it's securing, I think, $70 billion in the DeFi space. So there's a battle-tested component, right? There's an architecture that is working and that does work. I'm not an expert on a lot of these other Oracle networks. Have I checked them out and tried to work them with myself? Yes. Is there? But I will say there's a reason that I started working at Chainlink Labs, right? And the reason is because the technology is absolutely phenomenal. So that's kind of the answer. That's a really good question, though. Great question.
I've got a question here as well. This is more kind of with like specifics, but Chainlink supports external API calls, right?
Yes.
So how does that work with the network, with like the network coming to a consensus, right? Because an API call could result in multiple different results, I guess. How does that work?
Yeah. Let me get to the docs, since I don't know that I can answer this in 4 minutes fully. If you check out share my screen again. The docs, I don't know, can you see this? I feel like it's frozen.
It's the meeting
Oh,
screen.
did I do the wrong screen? My bad. That's the thing it warns you about not to do, because you'll make the infinite mirror thing. Yeah, so we have any API in the docs. It's just we were up here on data feeds. If you scroll down, it talks about it here and how to get data on chain here. There are jobs that do this, and so it's kind of a similar fashion of you need the network to do this to come to consensus, essentially.
Okay.
So it creates a job that's going to talk to the API and bring that data on chain, unless I'm...
That's right. Just to add to it. So the API call here is an example of, you kind of think of it as like the single smallest unit of an Oracle network, right? A thing in real life is made up of what? It's made up of a bunch of atoms. A decentralized Oracle network is made up of what? A bunch of oracles, right? In order for them to bring data on, each oracle needs to do its job, right? So calling an API is them, getting the data, right? Or calling most call multiple APIs actually. And then all the oracles, once they call the data, they'll talk to each other and reach some consensus, right? But this is like the smallest unit of gathering data, right? Or what you could also do, and this is some product or some networks still do this, is each oracle calls its API, returns the data on chain to like an aggregator contract, and that's where consensus is done, right? Now most of consensus is done off chain, and each node just signs their piece of data. It gets sent in one transaction. But yeah, so this you don't reach a consensus on what one API has returned. You reach a consensus about something in the real world. So it's not going to be It's not going to be like, hey, CoinGecko said the price of the ETH is $300. It's going to be the price of ETH is $300 based off of this decentralized massive collection of data that we've gathered.
Okay, cool.
Great question.
And one thing to point out, while that is getting data, it's part of the data feeds, right? It's not, the price feeds piece of data feeds is kind of like out of the box, like ready to go, already funded by those sponsors that we talked about. If you're adding an API call like this, you will need to like fund that with the Link token too, just to kind of point that out.
Right.
Cool.
Is there a
We got about
limit or
1 minute left, but
is there a minimum number of oracles that need to come to consensus on like these API calls? Or can you essentially just have one oracle?
yeah, we do require consensus, and like for example, on this ETHUSD, we would require 21 here.
What about for just like any API call? Is there a minimum number as well?
There is, I don't know, is it the same, Patrick?
Yeah, I can jump in here.
Everyone?
So at the end of the day, you want as many oracles as possible. Why? Why do you want as many oracles as possible? Security, and what else? What's the reason we do all this? More data points. Yep, that's good. Yet less chance of bad actors. Yes. I'm looking for one word in particular though.
Decentralization.
Boom. Thank you. Green peppers. I just noticed is that your name? Green peppers?
Sorry, I thought I changed it, but no, it's Evan.
Green peppers. Spot on. Yes, exactly. Green peppers. Decentrality, right? So the more nodes we have, the more decentralized the network is, right? So the question then is, okay, what's the minimum number? And that's where it's tricky again, right? Because you just want to have as many as possible. What's the minimum number of nodes you'd want to consider Bitcoin decentralized or Ethereum decentralized or Chainlink decentralized? Well, it's kind of this grayscale where the more, the better. So, right now, most price feeds have a minimum of 21, right? But that depends on the network itself. Right now, if we had a Chainlink data feed that had as many nodes as like the Ethereum or the Bitcoin network, like thousands of nodes, we would crash Ethereum. Like the Chainlink network would crash Ethereum. Why? Because there would be way too much data coming through in a single transaction. And no one would be able to pay for like the gigabytes of data of like all these thousands of nodes just signing transactions and signing data. So because of that, you have to compromise a little bit. Okay, maybe we'll go for 31 nodes, right? 31, that's a much more reasonable. You're still going to be paying a lot of gas. It's actually really interesting. Like a year ago, if you've ever seen like those gas charts, Chainlink was like constantly like number 4, number 5, just because of how much data was going on chain. And then some of the architecture of Chainlink changed and it dropped to like, page 3 or something like that, which was phenomenal. But yeah, so the question is, the answer is there's no real minimum. It's just the more the better. But the blockchains that these networks are on kind of constrain how many can go on there without bankrupting all these protocols and the node operators. Does that make sense?
Yes, sir.
You are, by the way, these are all like, you're all crazy on the ball. These are all amazing questions.
Are you guys ever gonna have support for Solana or Terra smart contracts?
Yeah, they just confirmed. Yeah, I think. That's all.
So you guys do? You support?
So, sorry,
smart
in
contracts?
my brain I was thinking words. Yes, if you take a look at the docs page, you'll notice the supported blockchains include both Solana and Terra.
Well, thank you so much.
That's a good question, though. Yeah, sure. Thank you all.
Much for coming to talk to us today. We'll definitely reach out to you on LinkedIn and follow up with any questions
Sounds great.
guys.
Yeah.
Yeah, thank
Have
you.
a good one.
And
Thank
we'll
you guys. That
relay
was
all your
super
contact
super
info.
informative. And I want to work at Chainlink.
We're hiring. I'm just saying.
That's the question though. How about like for a lot of us, with the space is so new, like there's never internships or anything like that. What would you just say? Just dive into it.
So yes, and I'm like 99% sure that I've talked to an intern at Chainlink. So yeah.
All right, I'll look for it.
Do the
I haven't
interns
seen
get
it.
to meet Sergey?
Yeah. The god.
So wait, let me add to Richard's answer here. So my favorite part about the blockchain Web3 space is that you're going to get drastically better experiences than being an intern, right? You think of interns, you think of like, that pencil pushing jockey who gets the manager's coffee. Like, no one wants to do that shit. Like, you want to be building stuff, you want to be doing stuff. And the thing about the blockchain space, the Web3 space, guess what? All that shit's out there. It's all open source. It's decentralized. If you want to get some experience, go to a protocol that you think is hot, that you think is cool. Go to the issues and be like, that looks like something I can work on. I want to do that. There's a hackathon every single month where college students, just like yourself, have won thousands of dollars just on a whim because they were like, hey, I'm going to show up. And then they go off and they build a 6 months ago, we had a group of developers. They won like $30,000 and they just did a seed round of like 5 million. And because they just decided, hey, I'm going to show up, I'm going to try this blockchain thing. And now they've started a multi-million-dollar company. Many of them get hired. There are recruiters that go to these hackathons. So in my mind, internships are less hype than just like going out there, jumping in the community and doing stuff, because you're going to get way, way better experience. Community is crazy collaborative. You can ask a ton of questions, jump into Discord, Stack Overflow, Reddit, list goes on and on and on. But you can get up to speed way quicker doing that than being a pencil pushing jockey. So that's just my 2 cents.
Hell yeah.
Motivational. Let's go.
You should hear him when he's fired up about stuff. Like that's like
Hey, we've seen all
What
your
was that
YouTube
then?
videos. We see you fired up all
low
the time.
energy, Patrick.
Yeah.
All right, thank you guys so much.
Yeah, thank you guys.
Thank you all.
Thank you.
Thank you.
All right, take care.